Hello everyone, and welcome. I am really excited to have you here because today we're going to begin learning one of the most fascinating concepts in artificial intelligence called reinforcement learning. Now, don't let the name scare you. When people hear the words reinforcement learning, they often imagine complicated mathematics, difficult programming, or pages full of formulas. The good news is, none of that today. In this lecture, we're not going to write code. We're not going to discuss algorithms. We're not going to solve mathematical equations. Instead, we're simply going to understand how reinforcement learning works in the most natural and intuitive way possible. Think of today's session as laying the foundation of a building. If the foundation is strong, everything we build later becomes much easier to understand. So, grab a cup of coffee, tea, or even your favorite snack. Sit back, relax, and let's explore this amazing concept together. Before we build intelligent systems that can drive cars, play games, control robots, or solve complex real-world problems, we first need to answer one important question. How does a machine actually learn? Think about yourself for a moment. Nobody was born knowing how to ride a bicycle. Nobody was born knowing how to drive a car. Nobody was born knowing how to cook. We all learned these skills somehow. But how? That is exactly the idea behind reinforcement learning. Let's imagine you are playing cricket for the very first time. You've never held a cricket bat before. You walk onto the pitch, grip the bat tightly. The bowler starts running toward you. You feel a little nervous. The ball is delivered, you swing the bat and completely miss it. The wicketkeeper catches the ball. No runs. You smile and think, okay, that didn't go as planned. Now, something interesting happens. Your brain immediately starts analyzing. Maybe I played the shot too early. Maybe I should keep my eyes on the ball. The next ball arrives. This time, you make contact with the bat. The ball rolls gently toward the fielders. You manage to score one run. Not a boundary, but it is progress. Your teammates clap and encourage you. You feel a little more confident. Your brain says, that felt better. Let me do more of that. A few overs later, the bowler delivers another ball. You watch it carefully. Time your shot perfectly. Swing the bat. Crack. The ball races to the boundary. 4. Everyone cheers. You feel excited. Now your brain has learned something important. Watching the ball carefully and timing my shot gives me better results. Did anyone stop the match to explain the physics of the bat? Did someone calculate the exact angle, force, and speed before every shot? Of course not. You learned by playing. You made mistakes. You observed the results. You adjusted your technique, you tried again, and with every ball you faced, you became a better batter. Another everyday example, imagine you are learning to cook for the first time. You decide to make tea. You add water, milk, tea powder. Then, without paying attention, you accidentally add salt instead of sugar. You proudly take your first sip, instant regret. That terrible taste immediately teaches you, never do that again. The next day, you make tea again. This time, you carefully add sugar. Your family drinks it and says, wow, this is really good. That appreciation becomes your reward. Without anyone giving you a formal lecture, you've improved simply by learning from the results of your actions. Let's take another example. When children first learn to ride a bicycle, they rarely succeed on the first attempt. They wobble, they lose balance. Sometimes they fall. Sometimes they get back up with a determined smile. With every attempt, they become slightly better. Eventually, balancing the bicycle becomes automatic. Nobody sits beside them explaining complex physics equations about balance and momentum. Instead, they learn through repeated practice and continuous feedback. Let's see rewards and consequences. Now, if we look closely at all these examples, we notice something common. Every action produces a result. Some results are positive, some are negative. Positive results encourage us to repeat an action. Negative results encourage us to avoid that action. This simple idea is one of the core principles behind reinforcement learning. But what about artificial intelligence? Here is where things become really interesting. Humans naturally understand rewards. If we score good marks in an exam, we're happy. If we receive appreciation at work, we're motivated. If we achieve a goal, we feel successful. Our brain naturally connects our actions with outcomes. But an artificial intelligence system doesn't have emotions. It doesn't feel happy. It doesn't feel disappointed. It doesn't know what success means. If you place an AI inside a game, it has absolutely no idea what it is supposed to do. It doesn't know whether winning is good. It doesn't know whether losing is bad. Everything is simply data. So, how do we teach it? Teaching AI like training a puppy. Imagine you've adopted a small puppy. On the first day, it doesn't know any commands. When it sits after hearing the word sit, you give it a small treat. When it ignores the command, you don't reward it. After repeating this process many times, the puppy starts understanding. If I do this action, I receive something good. Eventually, it performs the correct action without hesitation. Artificial intelligence learns in a very similar way. The only difference is that instead of biscuits, we reward it using numbers, positive numbers for good decisions, smaller rewards or no rewards for poor decisions. Over thousands or even millions of attempts, the AI slowly discovers which actions lead to better outcomes. Many beginners are eager to start programming immediately. That is completely normal. But imagine trying to drive a car before understanding what the steering wheel or brake pedal does. Wouldn't that be risky? Similarly, if we jump directly into code without understanding the learning process, programming becomes much harder. That is why this section focuses entirely on building your intuition. Once you truly understand how reinforcement learning works, the coding will make much more sense. Throughout this introductory section, we focused only on understanding the concepts behind reinforcement learning. We have seen how machines learn from experience, how rewards influence decision-making, how AI gradually improves through trial and error. And once these ideas become clear, we'll move on to implementing them using code in the upcoming sections. Reinforcement learning is inspired by one of the oldest learning methods in nature, learning by doing. Just like humans learn through rewards, mistakes, experience, and practice, artificial intelligence can also learn by interacting with its environment and gradually improving its decisions. Today's lecture was all about building that intuition. No programming, no complicated mathematics, just understanding the fundamental idea. Reinforcement learning is a type of machine learning. Artificial intelligence is the broad field of making machines behave intelligently, whereas machine learning is a subset of AI where machines learn from data or experience instead of being explicitly programmed. Finally, reinforcement learning is one of the learning methods within machine learning. In the next lessons, we'll dive deeper into the exciting world of reinforcement learning and see how these simple concepts allow machines to perform extraordinary tasks. So, grab your coffee, stay curious, and let's begin this exciting journey together.